Hello everyone, welcome back. This is a new project that I'm going to start right now, and it's a very interesting project. This is a 60s 1 gigahertz oscilloscope with sampling technologies, if you can believe that. Well, it's an awesome instrument, and the instrument is off at least in the last 30 years. So it's a very difficult challenge, I believe. I am not even if can be saved, but this is my intention. So just try to bring back to life and see if we can put in the right state to be fully operative. So I will flip over the instrument and see the back, and then I will remove the outer case and see how it's inside. This is the rear of the instrument. Here we have a plug, I believe to be for camera or for some other external accessories or instrument. Here we have the 2-channel output and the time-based output. I believe those were intended to be used with an XY recorder. This is an external scanning signal input that should replace the horizontal section, if I'm not mistaken. I just have I give it a quickly read on the manual, so I can make some mistakes. This is the fan. This is a bit hard to turn. It's missing the air filter, as well as the original screws that hold the case to the instrument itself. Also the plug-in, look at that, very weird plug-in without the ground terminal, which is really odd and danger. So the plan is remove the outer case and see inside, and decide the strategy to attack this beautiful instrument. As you can see, I'm in the middle of the removal from the case. You wouldn't believe the weight of this thing. It's absolutely super heavy, and despite it's really a pleasure to open an instrument such this, it's really heavy. So let's see if I can slide out completely without any damages to the instrument and to myself, and then see how beautiful it is inside this instrument. This is the upper deck, and this is the vertical plug-in that I'm going to remove. I already have seen that somebody has been in and replaced the original transistor with some other kind that I will see later. I'm going to remove the plug-in. As you can see here, we have also the original probe, and later I will show you I also have a second plug-in identical to this with 2 probes. One is partially dismantled. I'm not sure that I can save the second plug-in. I will try. So as said, I will remove the plug-in and then flip upside down the instrument and see how it's in the lower section. Just a quick view how the vertical plug-in section looks like. So let's flip over. Well, this is really lucky. Flipping over the instrument, and this is the bottom side of it, I found this small piece of plastic that belongs to this, so I can also repair the probe holder. And since I have this in the second plug-in unit another probe, I may use these two holders to attach both of the probes. So this is the bottom, as said. Here we have the input filter capacitors, the voltage regulator section, if I'm not mistaken. Here we have the series transistors that are held in this heatsink that is cooled by fan. Here we have more stuff, I believe to be trigger, maybe, or time base, can't really say in this moment. And this is the, yeah, this is the horizontal section. So, okay, I already have seen some crustiness here. Look at this capacitor. Actually, I believe to be only the plastic sleeve that is damaged. This kind of capacitor rarely fails since they are in oil. So I have to say that rarely I have found some failing, but look at this. Seems not really happy. As well as those one. And perhaps also that. Okay, before go ahead, I just want to show you how big capacitors are in this instrument. And this is the CRT, which I believe to be a special CRT because of the speed of this instrument. So the very first thing that I will do is the cleaning of the front panel, since it's very dirty. After that, I will start with capacitor reforming attempt and see the state of that. And I'll back and let you know how it's going. As ever, to give a good cleaning, all the knobs should be removed and washed by themselves in a separate bath. The removal of the knob, since they have two grains, allow you to check for control smoothness and bent shafts and things like that. So it's a good idea to remove that. I believe that this is not original. It has been added for some reason, maybe for some time measurements or just for fun, I don't know. I'm not really sure that is suitable or usable on this instrument. Of course, I think I don't have mentioned it so far. The model, sorry, is upside down, is 185B. So this is how the instrument panel looks like without all knobs before the cleaning. So let's see the result after that. Not bad for the age. The front panel came out pretty shiny, and all the controls are in very good condition. I still have to polish the BNC connectors, but I will address later. Also, the lettering is in very good shape. So, time to go to the electronics on this instrument. While I'm reforming and checking the capacitor, I just seen this date that should indicate manufactured in 1962, the 17th week of that year. So it's almost 60 years old. Not too bad. First capacitor that is faulty is C418, which is right this one, and it is sleeved with this cardboard sleeve, and as you can see, it's rated at 120 microfarad, 350 volts, and it is leaking very badly, is not recoverable and must be replaced. But what I'm going to do is to restuff this one, And instead of damage the bottom here, I'm going to cut the top of the can, extract all the content, and slide in a new capacitor. So let's see the final result. This is the restuffed capacitor. I left the terminal very long in order to pass through the holes that I have done in the original terminal. This will be the cover. I will just put a drop of glue, and then I will fit the cardboard sleeve again. So let's see the final result. I just have cleaned all the knobs, and I wish you to show you the rear of this knob. This is a large flanged knob. So people that are familiar with mechanical tool machines, they certainly know that need a grinder machine, the precise grinder machine, to have this type of finishing. So they put very high care on manufacturing this thing. That is a very precise process for such knob. This is the final result of the restuffed capacitor. This is just pressed in, so it can be removed and restuffed anytime we want. And this is the result on the other side. To me, it's a pretty clean job. I've just finished to test all the capacitors. Some of them were faulty, leaky, like this one. Well, actually, all the 10 microfarads capacitor seems that fails. Perhaps the type of capacitor has a weakness in the construction, as you can see here, there. So in total, I have replaced 6 capacitors. I just show you in a minute. Look at that. Plus this one, 150 volts, still 10 microfarad, which is right behind the instrument. I left this instrument on it, on this capacitor, since I have checked all of them for leakage and value with this, but I also want to be confirmed by this that the ESR is not bad. And this is the last one. Well, it's below 1 ohm and below 1% of loss. I can accept this. Of course, it's not brand new, but seems working. No leakage at all, so that's fine. So I think that's it for this video. In the next one, I will go to the test of the vacuum tubes, the reassembly of the front panel, and start to try to power it up. So thanks for watching, and see you very soon.